going to go ahead and start 6, 7, which is where we're going to prove that some kind of figure is a certain quadrilateral, but on a coordinate plane. So if we're on a coordinate plane, we need to use our distance, midpoint, and slope formulas. So let's go ahead and write out those formulas just as a little refresher. So we've got x2 minus x1 squared plus y2 minus y1 squared. All right? Then midpoint is where we should get a coordinate for an answer. We add our x's, divide by 2, add our y's, divide by 2. Then lastly, slope is where we have rise over run, so change in y over change in x's, y2 minus y1 over x2 minus x1. All right, so let's figure out when we're going to use those formulas. So we've got this table here that's going to organize it a little bit better for us. So if the shape is a parallelogram, that's what we are going to prove. Then there's actually a couple ways that would be the easiest to prove it, and we're just going to give you those. So with a parallelogram, I am actually going to give you 3 of them because it kind of depends which ones you remember and which one you would like to use. So the first one would be opposite sides parallel. That would prove that a shape was a parallelogram. And remember, if we're doing parallel sides, we'd be looking at slope. And we'd be wanting those slopes to be the same if they were on opposite sides. The second one would be opposite sides congruent. And if we're finding if 2 different sides are the same lengths, you would use distance. So these 2 are probably the first ones you're going to think of, but a little bit more tedious. So your last option, which is the easiest, is that diagonals bisect each other. And you could know that diagonals bisected each other if you used your midpoint formula on the 2 diagonals and they had the same midpoint. Okay, we've done that on a note sheet or an example before. Okay, so now let's go on to rhombus. The easiest thing to prove, the first thing you're going to think of, actually, I should say, would be that all the sides congruent. So all sides congruent, and you would use distance. So anytime you're looking at lengths and you want them to be the same, you would use your distance formula. The second way, this is the easiest way. It's always easiest to use your diagonals because it's the least amount of work. So we know diagonals are perpendicular with rhombuses. That's the symbol for perpendicular, okay? So if we're looking at parallel or perpendicular, you are using your slope formula, okay? And if we want them to be perpendicular, if you want to write, we're going to use negative reciprocals, okay? That's the easiest way to prove something is a rhombus. Now, a rectangle, the easiest way to do it is to show that diagonals are congruent, okay? That's how we did it on our 6-4 to 6-5 notes. We actually did it that way and showing right angles with our slope formula, but that way it took a long time. We're just going to use this one, which if we want them to be congruent, and those are lengths, we'll use our distance formula. Okay, so these aren't covering every property of all these shapes, but the easiest ones that you should go off of to prove it if you were on a coordinate plane. All right, now a square. Remember, squares have to be pretty specific, so you need both of these, okay? Make sure that you note this, all right? So the first one that you should use, that would be the quickest, is diagonals congruent, which we would use distance formula for. And because this property comes from a rectangle, we also need one from a rhombus. And I'm going to use the easiest one from there, which is diagonals perpendicular, which we're going to use slope for. Specifically, we want negative reciprocals again, since we're looking at perpendiculars, okay? So you need both of those if you want to prove something is a square. Next, you have an isosceles trapezoid. Easiest, best way to prove an isosceles trapezoid is to check if the legs are congruent. Again, lengths congruent, we are using distance formula. And then with a kite, your easiest one to use would be diagonals are perpendicular, which again, we use slope for, specifically negative reciprocals. Since this is the same property and way that we're doing this for a rhombus, you just need to make sure that this figure is actually a kite. So the difference would be make sure all sides not congruent, okay? Because if all the sides looked like they were the same length, that's going to be a rhombus. But remember, a kite has probably two that are shorter and then two that are longer. So make sure it looks like a kite, and then you can use the diagonals perpendicular to prove it. All right, let's go on to 3 examples real quick, okay? So here's the first one, is the trapezoid and isosceles trapezoid explained? So the way we're going to figure this out is that ask ourselves if the legs are congruent. So here are my legs, AB and CD, okay? So these coordinates here, A is at -1, 3, B is at 2, 1, C is at 2, -1, and D is at -1, -2. All right, so now we're going to use our distance formula. We are just going to check, is AB congruent to CD? So let's do this distance formula here. We're going to have x2 minus x1 squared plus y2 minus y1 squared. We'll plug that into our calculator. So go ahead and do that. And we get that this length is 3.61 if we're rounding to the hundredths place. I'm rounding to the hundredths because I want to be pretty specific to make sure that these are going to be exactly the same for the most part, okay? Then I'll go ahead and do CD, check this distance as well. So x2 minus x1 squared plus y1 minus y2, or y2 minus y1 squared. Okay, oops, so I have these in the wrong, or no, these are in the correct order. Yeah, all right, and so if you do this, you actually get 3.16, okay? So these are not the same, which means, is this an isosceles trapezoid? No, because legs not congruent, okay? So since the legs were not congruent, we can't say this is an isosceles trapezoid. Let's go ahead and flip it over. All right. The instructions on this example should be telling us, this would be example 2, it should say classify the quadrilateral. So your first step would be to plot these points. Either draw in a coordinate grid or they might give you one, okay? So let's go ahead and plot these points, -6, 3, 1, 2. Here's where point A would be. Then we have B at -2, 0. We have C at -2, -5. And then we have D at -6, -2. Go ahead and connect your lines the best that you can. And what you should do first, so step 1, use just some common sense and ask yourself, what does it look like? Okay, it definitely does not look like a square. Definitely does not look like a rectangle. I don't have right angles. All right, to me this does not look like a trapezoid. I guess it could be a kite, could be a rhombus. I'm probably going to go, it kind of looks like a rhombus. Okay, so I'm going to go with that. So I'm going to check if this is a rhombus. So step 2 would be to check. And to check for a rhombus, the easiest way to do that is check if your diagonals are perpendicular. So I'm going to check the slope of AC, and then I'm going to check the slope of BD. And I think the easiest way to do this is count rise over run. So from A to C, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. Since I went down 8, it's a negative 8 on top. And then 1, 2, 3, 4 over 4. And this simplifies to negative 2 for the slope for AC. Now, I'll go ahead and find the slope of BD. Start at the left point. I actually have to go up to get to B though. So 1, 2. That's how much I had to go up. And then I go over 1, 2, 3, 4. And 2 over 4 simplifies to 1/2. Since these are negative reciprocals, then I know they are perpendicular. So this shape is a rhombus. These questions will, majority of the time, be multiple choice too, so you'll have some options that you should check, and you should go off of what it looks like as well. All right, last question. They love to give you this kind. Quadrilateral ABCD has the coordinates A, B, and D. So you have to figure out if this is a square, what could the coordinates of vertex C be? So step 1, let's go ahead and plot these points. So point A is at -3, 2. We have point B at 2, 5. And then we have point D at 0, -3. Okay? We can connect these. And then we can try to think of where C would be. If we're trying to make this into a square, it's got to be somewhere kind of like in this area, all right? You don't have to draw in that circle. I just kind of want to point that out because if you have multiple choice options, make sure that the point makes sense. You can plot it and see if it looks like a square. Now, what I would do is use slope. And I'm using it kind of with distance. So the way I'm going to do this, and the easiest way to do this, is kind of ask yourself, all right, how am I getting from A to B? So I'm going up 1, 2, 3, and then 1, 2, 3, 4, 5. So I went up 3, then right 5. So from point D, I'm going to do the same thing. So this was to get from A to B. So to get from D to C, I want to do the same thing, okay? So I'm going to go up 1, 2, 3, and then over 1, 2, 3, 4, 5, okay? So that's where I'm going to put point C, and I'm going to connect these and see if that looks like a square. It definitely does, and then you can go ahead and check the other ones too. Go from A to D, I'm going 1, 2, 3, 4, 5, and then 1, 2, 3. Still involves 3s and 5s. So check down 1, 2, 3, 4, 5 over 1, 2, 3. That still worked as well, okay? And this will work. It means that all of our lengths are all the same because it all still deals with 3s and 5s. And it means that all of them would be parallel. So we know point C is at 1, 2, 3, 4, 5, 0, okay? And that would be how you get your answer. All right, bring these notes filled into class and we'll do some more practice and review for your next test.